first topic of this semester is work. So, what is work? You guys might be thinking of jobs. You know, if you work at a grocery store or a restaurant, or my work is teaching, but not quite the same thing in physics. In physics, work is a force applied over a distance. Alright, key things to recognize there are the force and the distance. Okay? The equation for work is work equals force times distance, or you can abbreviate that as W equals F times D. Now, as you've known or seen before in this class, typically you're not always just solving for W. You might have to solve for the other variables. Alright, so say you have to solve for force. You have to get force by itself. In order to do that, you have to get rid of that D or distance, so you divide by it. And that's how you get this one. Alright. Now let's say you have to solve for distance. Very similar way of rearranging the equation. This time you want to get this D by itself. So you're going to get rid of the F by dividing it out. Alright. And that's how you get this one. Alright. Now, you also want to focus on the units. The units come from the parts that are in the equation. So, think back to last semester, what are the units for force? Hopefully you remember a certain famous scientist called Newton. And what are the units for distance? Distance is length. In the metric system, we call those meters. So your units are a Newton times a meter for work. Now, a Newton meter has its own name. So 1 Newton meter is 1 joule, which you can abbreviate with a capital J. Alright, so the joule is the unique unit for work. Alright, but that's also equivalent to a Newton meter. So, variable relationships. We've dealt with this before. This is whether or not the parts of the equation are directly related to each other or indirectly related to each other. If you remember, a direct relationship means they both either go up with each other or go down with each other as you change them. Inverse means that as one goes up, that forces the other to go down. So, one way to think about this is to actually play around with the numbers. Let's say we have 1 joule of work, which is going to be equal to 1 Newton of force applied over 1 meter. Alright, so if you plug that into the equation, you've got 1 times 1 equals 1. So let's say we want to determine the relationship between work and force. So we're going to leave distance alone. We're going to keep that as a 1. But let's increase force. So let's make that 2. If we double the force, it's increasing from 1 to 2. And that's going to force, in order for our equation to still be true, is going to make the work 2 as well. Alright, which means the work increased. So they both got bigger together, which means it's what type of relationship? Alright, if they're both increasing, that means you have a direct relationship. So force and work are directly related. Alright? So let's do the same thing with force, or with distance and work. So this time, force is going to be left as 1. I guess let's write out the 1 times 1 equals 1 part. We're going to leave force as 1, but this time, let's triple distance. Alright, that's still increasing it, making it bigger. So what's 1 times 3? That makes 3. So as distance goes up, so does work. So they're both going up together. That means work and distance are directly related. Alright? So work is directly related to both pieces of its equation. If you increase the force, that'll increase the work. If you decrease the distance, that'll decrease the work. Okay? Just something to keep in mind. Other things that you might be doing with this equation is solving for work, solving for force, solving for distance. So here's a couple sample problems. Alright? So So we have a 20 kilogram object that has moved a distance of 5 meters by a net force of 50 newtons. What is the work done? So if you remember from last semester, we had that whole lasso system. That comes in very handy again this semester. Alright, so the first thing you want to do is list out what you know. And it doesn't hurt to list out what you're supposed to find. Alright? So your knowns. We know that there is a mass of 20 kilograms. We know that there is a distance of 5 meters. And we know that there is a force of 50 newtons. Now, what is our unknown? What is it asking for us to solve for? That's our work. Alright? So we want to find, next part is our equation. We want an equation that is going to involve solving for work and using some of those variables. Now, this one might be a little on the tricky side because do we need the mass? Alright, we just learned that work is equal to force times distance. So we're going to use that equation. It means that this mass number doesn't help us at all. We didn't need to know it. It's not going to go into the equation. But everything else is going to be used. So, next S is substitute. So we're going to plug in our distance for our distance and our force for our force. So we have here our 50 newtons and our 5 meters. The next S is actually solving that. So that's 50 times 5, which is 250. And then the U is for our units. And what are the units for work? If you recall from a couple slides ago, you can label it as either Newton meters or as joules. Either one works. So that's one type of equation. Another type of problem you might have, here we have a machine that does 500 joules of work in order to move an object 25 meters. Alright, and then this time it's asking how much force does this apply. So again, remember, lasso. So we're going to list our knowns and unknowns. So we know that there's 500 joules of work, so we know W, and we know that there's 25 meters. Because the unit is meters, that tells us that's distance. Alright, so distance will be in meters or some sort of length. So, and our unknown, which I boxed over there, what the question's actually asking for is force. So we want an equation that's going to solve for F and have W and D in it. Alright, so we know that there's work equals force times distance. If we want to get force all by itself, we have to get rid of that D. Right? So our equation is that one right there. Let me get these numbers out of here. Alright, so we're going to use this one. So next, we're hitting our first S, so we're going to substitute what we know. So we put the 500 joules in for W right here, and the 25 meters in for D. Then we're going to solve that. 500 divided by 25 is 20. And then our last thing we want to make sure we never forget are our units. And what are the units for force? Hopefully you remember that famous scientist called Newton. So that's solving for a force, given work and a distance. So, one more type of problem you might see is here we have, if it takes 650 joules of work to apply 100 newtons of force to an object, how far does the object move? Alright. So we want to use lasso, starting with listing our knowns and unknowns. So we underlined 650 joules of work, and we underlined 100 newtons of force. So that's what we know. And then our unknown is our distance, because how far is a distance? So we need an equation that has all of those pieces in there. So we have our work equation, but this time we want to get the d by itself, so we have to divide by our force. Alright, which looks like this. So this is the equation we're going to use. D equals work divided by force. So we're going to plug in our knowns where they belong. So our work goes in as 650 joules. Our force, or F, goes in as 100 newtons. Next, you're going to actually solve that. So 650 divided by 100 is 6.5. And last thing is figuring out your units. So what would the units be for a distance? Hopefully you are thinking of meters. 6.5 meters. So, I've shown you how to do each type of problem. Alright, all you have to do is rearrange for the variable that you want to solve for. Make sure you know the units, make sure you know the equation, but you have an online assignment, so make sure you click on that link to the Intro to Work assignment and make sure it's done before 7:20 a.m. Tuesday, January 8th. See you in class.